This conference will now be recorded.
Are marked for deletion, and the new partition 5, 6, 7, 8 are there for you with the query in the table. Okay, whenever you repartition, that's what happens. Okay, how do you cluster it? Create or replace table T1, C1. So if you want to create a cluster while creating a table itself, cluster by C1, C2. Show table selective by expression. If you want to have some date, we talked about timestamp is very, what do you call it? Um, Too many distinct values. Do we call that particular high cardinality? Okay, so and then if you want to, you can do a clustering on the JSON as well. If you have a JSON, right, you can by path create or replace table. We are trying to cluster by data ID number. So if you have a JSON table and then if it's more than terabytes of data and if you want to cluster, you can cluster it as well. And if you want to change the cluster key columns, alter table T1, cluster by C1, C3, C2, you can just, the moment to cluster, automatically it goes and deletes all the old partitions and orders the data according to the new and all this stuff. Clustering. Now, previously it was manual clustering, if now it's all automatic clustering. So it helps you to ease of maintenance, full control, non-blocking DML. You can still do DML activity, optimal efficiency. Okay. So and the credit and storage impact, we talked about it. Whenever you do the clustering part of it, all the old partitions are marked for deletion and they're kept for time travel only. And then the new partitions get created based on the cluster that you have created. And you have to pay for the compute charges if you have to pay for the storage charges. Okay. And if you want to, if you have enabled auto clustering, that means you created a cluster and then automatically it clusters whenever needed. If it thinks that and I don't see what is the when does it kick the auto clustering thing? When does it recluster, right? That particular part, I'm not sure. So they might have some algorithms to identify when do they want to recluster. So if your table is very deteriorated with DML activity, and then they might go and recluster automatically. And if you want to query and see the automatic reclustering, right, there is the information schema function, uh, automatic clustering history and date range give, and then it will give you this the query for querying the automatic clustering history. If the table has been automatically clustered or not, if you want to check, this is the metadata function. And if you want to do check on a table name, then you can pass the table name as well. Here you can just pass the dates and then it goes and shows you if there are any automatic clustering happens or not. So automatic clustering history is the name of the view, sorry, name of the function that we normally use from the information schema. Okay, and then so the other part of it is right. Whenever there are three kinds of cache. So result cache, metadata cache, and virtual various cache. This is part of the, what do you call it, interview questions that people normally ask you. How many kinds of cache are there? Can you tell me what are there and what is the difference between them and all this stuff? So we have seen the result cache. If you all query results stored for 24 hours unless underlying data changes. Identical queries are written instantly without requiring compute. So similar queries, if you are running one more time, then it's reading from the result cache rather than going to the table. The compute your warehouse is not compute warehouse is not utilized. But if you start using the result scan function, if you just plainly read from the result scan function, then the what do you call the compute warehouse is not your custom compute warehouse, virtual warehouse is not used. But if you start filtering the data based on the result scan function, right, then the warehouse will be used. Okay, so that is the result cache. And then metadata cache improves compile times for queries against commonly used tables. So if you are trying to use some query tables in your worksheet constantly, right, and then whenever you are trying to, so that means the metadata is already cached for that particular tables. So it becomes easier to um, the when you run a query, right, the metadata of that particular commonly used tables. But if commonly used means you have run your queries before on the table, you did something, and now you are trying to run query on the same table with a different where condition and something like that, right? The table metadata is already cached, so it becomes easier for Snowflake to compile the query. The compilation becomes much more easy because it has all the details for the commonly used tables. That is called metadata cache. Okay, and then virtual warehouse cache. So virtual warehouse, whenever you use virtual warehouse, right? That means it goes and gets the data from the S3 buckets. So it caches. That's called SSD cache as well. Okay. So whenever you run your query, it goes and then reads from the virtual warehouse if it's already there. That this normally helps. For example, if you're running queries, running a report, and then there is another developer who is running the same report with the different filter conditions, and they're trying to access the data from the same table, same set of data and all this stuff. So in those scenarios, what happens, um, the cache that is there on the virtual warehouse will be served for both the people. The result cache is only for you, for the user within the session. But virtual warehouse is if any of the people are using the same virtual warehouses. For example, report warehouse. If I am using report warehouse and you are using report warehouse, and then if we are executing the same similar queries, right? And the warehouse is already cached data from the table, so it will serve you from the table. Sorry, it serves you from the cache, which is much faster. Okay. So that is called virtual warehouse cache. And whenever you auto the parameter, we set it auto auto resume, and then what was the other one? To
Auto suspend.
minutes or 5 minutes, and if the virtual warehouse is idle for 5 minutes, then it goes into the suspension mode, right? We talked about it, right?
Yes, sir.
So whenever it gets suspended, all the memory, that means the if you five people are using, and then the cache is already there on the virtual warehouse, and then when it goes suspension mode, right, and when you issue a query, it wakes up, but the data that is cached is gone as when you when the virtual warehouse gets suspended. Are you able to follow me? So setting up very small or setting up large, you have to come up with an optimal auto suspension parameter. If you set it up very less, right, it sleeps happily within 2 minutes, and you save some credits. Whenever it wakes up, um, But the problem, whenever it wakes up, you have to pay for 1 minute billing. And whenever you resize your warehouse, you have to pay for 1 minute billing. And then when you wake up, if you suspend the virtual warehouse, right, the cash that is sitting on the virtual warehouse is gone. So you lose some of the performance. It has to go and read from the S3 buckets again and get you the data. Are you able to follow me?
Yes, sir. Sir, I have two questions here. So, so before it getting, hello,
So that is the downside whenever you suspend the warehouse. You have to make sure. When you're in the
hello,
warehouse, this cash is gone. Okay.
hello,
When virtual warehouse gets suspended, cash is gone. Yeah.
sir, can you hear me?
Did you ask me a question? 10 guys ready?
Yeah.
Yes, yes.
Sir,
I can
I
hear you.
have, I have a question here. Like before it gets data from the cache,
Hmm?
it has to compare, right, whether the data got changed, any DML operation happened on the table or not. So how does it come to know, sir, that one?
So this happens both in the user the session as well as virtual warehouse, right? So they have an algorithm in metadata. The moment you the result set data that we are trying to query. So whenever that particular data set is updated, right? What happens whenever you do a DML activity? What happens? Automatically it
Micro,
reorganizes the data. Micro partition gets
micro.
reorganized. That means
Yes,
when it's
correct.
reorganizing, if it goes and checks in the metadata if any of the data is cache, and then if it's based on that, it invalidates the cache. And same thing happens on the virtual warehouse as well.
Okay. Okay.
So whenever
And
it,
one more thing, sir. One more question,
mm,
sir. So we have, let's say, for example, I have sales table, select star, first time I have queried
mm,
select star from sales. Okay.
mm,
So second time, if I issue query without result scan, I am issuing select star from sales table, where
mm,
country equal to some country, India I have given. Okay. Now
mm.
will I get the data from Kashi or S3? Why? Because the syntactical changes are there. But
Yes, it goes
but
and gets the data from. Uh, it might get you from the virtual warehouse cache because it would have got all the table data.
yes, okay,
It
okay.
uses it uses compute. It uses your virtual warehouse. That means it goes and gets the data from the S3 buckets.
But there is a where clause, no, sir. As just you told, like where there
But
is a changes or where clause that
Yeah,
has
that's
to
the
get
reason
it
it goes
from
on.
the S3.
It doesn't use result cache. It goes and gets the data again.
Okay.
so
So
result set is already available now, sir. Full set is available in the cache.
So
So why should it get from S3 buckets again?
that is true. But how does the optimizer should have all? We can check it out 1 second.
Yeah.
If the table is small and if it's cache, it might not go. I'm not sure, but that's what it is. Select star from EMP, right? So if you go to warehouse, history part of it, select star from, it did not use because it went to, what do you call it? Select system cluster. Where are we right now? Select star from EMP because we would have given it in the morning and then it's fetched it. So
Sir, you're not audible, sir. Sir, you're not audible, sir. We cannot hear anything.
Guys, can you hear me now? Hello?
Yes, yes. You
Yeah.
can hear, sir.
Yes, Bhaskar, can you make me a host? Go click on the people icon on the top, and then next to my name, just click make me a presenter. You did? Yeah. So I'm gonna share my screen. So if you look at these particular SQL right, they are using even though if they got all the data, department manager, they used your virtual warehouse. Okay. And if you go and then click on this particular SQL, full table, it doesn't share anything. So there are two partitions, it scanned two of them and got you the data. So that is pretty much about it. Okay.
So main
And
is showing as 0%. Table scan is 0%.
this one zero, this one.
Yeah.
It did not read from the cache. It went. I'll explain you. I will talk about the query profile part in the next couple of minutes. Okay.
Okay.
And then what happens when people might ask you what happens when you issue a SQL statement? What happens inside SQL? So inside Snowflake. Query issued by Snowflake, whether it's via standard or
Shekhar, sir.
SnowSQL or yeah.
Yeah, one question, sir. Could you please go to the last slide? So I was being asked like out of three caches, which one is faster?
Result cache is faster. It's only specific to the user and it's there, it is in the metadata. So whatever you're trying to query from the metadata is much more faster.
Okay, thanks.
Okay. So query received by Snowflake, it goes and looks for the metadata result cache whether this particular thing exists or not. Query matches an entry in the result cache, then result cache is returned immediately. Then it goes for the planner optimizer. It goes and checks how do we get the data and all this stuff. Prune and filter, then use metadata to identify exact data to be processed. And then virtual warehouse processing. The virtual warehouse comes into the picture, scans only needed data from local SSD cache. This is what the virtual warehouse cache. If it has something, it gets from it. Or Amazon S3 processes and returns to cloud services. Return set result set return. Final result set processed and stored in cache for future use and then returned to client. So you understood, right? It goes, looks at the result cache. If not there, it goes and looks in the virtual warehouse cache. If not there, it goes to S3 buckets to get your data. And then what happens? It results to the cloud services layer to metadata, and the results are cached there, and it results to the client. Okay. Okay. And then next, coming to the query performance part of it. Okay. So whenever somebody is asking you about tuning, what you have done in your Snowflake, and can you please tell me, explain me what is the performance aspect of work that you have worked upon, right? I have given this particular slide deck. If you have this slide deck handy, or you can copy all this stuff into some um, sticky note on your laptop and then talk to them, that's also fine. So this is first thing. We'll make sure that our subqueries are very bad. Okay, so don't use subqueries in your query. And in the afternoon, I've seen a scenario where using a subquery they are trying to update, and they were able to update only 300 records. It took about 28 minutes. So you have to make sure subqueries are not written, and check for subqueries and correlation subqueries in the main query. If they have given you a task, so now I have given you a SQL. How do you go about tuning the SQL? What are the aspects you consider normally to tune the SQL? Means first go and look for queries or subqueries. Snowflake is bad and correlation subqueries. Okay. The reason we have looked at it, whenever you are using subqueries, pruning doesn't happen properly, right? Data pruning doesn't happen. That's the reason it has to scan too many partitions, and then it takes a lot of time. That is a part of it. Check for join condition. Look for missing joins or Cartesian products. Something like
Sir, one doubt, sir.
hmm,
Actually, for the real-time scenarios, when we write the complex queries, right, we
why
mostly
not?
use the subqueries.
No, we don't encourage writing subqueries. You can real time
Yeah, yeah,
scenario. We have to avoid subqueries.
that is right. But actually, when we compare with the Oracle, no, Oracle is working better for subqueries, right? In the future,
Yeah.
like Snowflake also will be going to solve that problem, or it will
Eventually,
be.
no, going forward. See, Oracle architecture is different. This Snowflake architecture is different. There, you create a table, you create indexes for the performance. The way that they store the data is different. Here, it's all micro partition. The way that the data stored is different. It scales for millions of records. Oracle doesn't. scale much when compared to snowflake. So there are a lot many differences. We cannot compare. So these are like apples and oranges when it comes to the technology part of it. So each of them have their own pros and cons. So these guys are bad in subqueries. Eventually, they might become better. I'm not sure.
Okay, actually, in where we are in the project, right? So
Hmm.
there are many scenarios where we have got the subqueries from customer. So we were not going to change anything because it should be like that only. So in that case, we don't have any option to change the query also. So
Now,
how
if
we
you
can
don't
change?
change it right now, eventually you're gonna burn more credits, and then the later part, you might be in the first stage of migration where you just want to make sure the queries are running fine, and you are happy. And after a while you start looking at the your monthly bill, and then you identify why I'm spending this much money, and then you start digging into the queries, and then why is this query taking a lot of time. It should have been finished in 30 seconds, why is it taking 3 minutes or 4 minutes. Then you have to tune that. So that is the next process we normally do.
What? Okay, got it.
Okay.
Thanks.
Sir,
Sir,
what best can be done to avoid subqueries?
Sorry.
What best can be done to avoid subqueries?
You rewrite the query without using subquery, using a join or something like that. Or the subquery table, you insert into a temporary table and use the temporary table to join into a main table. You have to come up with some alternative.
And
Okay.
also we can use it with the class also. We can use with the
Sorry.
class and then
Yeah,
with
with
the
class
class.
can be used. You have to come up with some different scenarios. Okay.
Okay.
So if you look at it, right, you can do an explain plan on the query. If you have a complex query, if you want to see how the query works, right? So this is the explain plan. Okay. And then this is how the data is retrieved from the table scan, employee number, expressions, and then filter. It's doing a department number filter, and then the result set. So global statuses, I don't see anything here. So when you go and look at the explain plan, it tells you whether it is using a Cartesian product or not. That will show you one more line which is Cartesian or not. If it's Cartesian, on which particular table it's Cartesianing on. So make sure that you are not getting into Cartesian products. For example, select star from EMP, comma DEPT. What happens? I don't know whether DEPT table is there. Object DEPT does not exist. Okay. Guys, can you hear me? Hello?
So we can hear you.
Now we can hear you, right?
Yeah, I lost you for a while. So when you look at this particular thing, right, I am not giving any joint condition here. There is no joint condition between employee and department. I'm just coding the data. You see quotation join here.
But internally, natural join happens, right, sir? Based on the
No, no,
keys.
no, no. Yeah, so it gets you all the entire data and it filters based on the department number. That's it. It joins all employees with all departments and then on top of it, you're filtering. But this is an expensive operation that you're doing, joining all the data. It's not good. Okay.
If you put proper
And
on condition there, I mean join condition there, so will it
yes, yes,
not be
yes, yes.
generating the
Yeah.
cross
No, it
check?
won't generate if
Yeah.
you go look at this particular thing, right? Where see the quotation is gone.
Yeah, sir. We are good now. Yeah.
So so you will look explain plan your SQL and see if you see any quotation things there. Okay. Check for proper filters when you're trying to join. Make sure that you have given proper filter so that it can filter most of the data. Okay. Is the query queuing, not executing at all? That means previously the query was running fine within 30 seconds or less than a minute it was getting executed. Now it's running more than 4 minutes or 5 minutes. So you have to go and look at the Veros load monitor graph and see whether any of the the load is too much on the system, and why is this particular is there any queuing happening on that, and then go check it out. Okay, that is one question. Is the query creating more rows than expected? That means sometimes um, whenever you are trying to join two conditions, there are two tables or three tables, for example. You join between A to B and B to C. Still, your data gets filtered out. But you forgot to join A to C, A to B, B to C, but not A to C. So when you have this kind of scenario, right, the table when it joins, right, it has too much of data getting from two different tables. That is called row explosion. I'll show you an example on that. We'll go through all these scenarios and then I'll show you. Okay. And you see that means whenever you join, it's getting too much of data, millions of records, and then on top of it, it's trying to filter out. It shouldn't get that many number of records when the join happens, right? So you have to look at what kind of join is happening, and then you try to analyze that, and then why is it getting to that's called row explosion. I'll show you a scenario, okay? And in this query spilling to local or external storage, sometimes what happens, right, when you are trying to do too much sorting, too much group by and a huge set of data and all this stuff, right, the memory is not good enough for the virtual warehouse. It spills into the S3 buckets for sorting purposes, and then that takes a lot of time. So that is called spilling to the external storage. So is the query not using pruning as well as it could? So that means whenever you're trying to query the table, it's scanning too many partitions rather than scanning less number of partitions. This happens when you use subquery. Okay, so you have to look at those kind of queries and try to modify them, tune them. You sometimes what happens, right? This might be because of the table join order. First, you have joined a table between A and B, and then B and C. If you have joined A and C first, then you would have not gotten into these kind of scenarios. This also we'll see. Are there any problems with the join order? Yeah, this we have to see both of them. Okay. Sometimes the expectations for the query performance based on having it seen running very quickly in the past. Check understanding result caching. So sometimes whenever the users may complain, I was running this report, it was coming pretty fast. Now it's taking a lot of time. Maybe it was running very so on the weekends. the virtual warehouse that he was using was suspended, and then Monday he came and ran the report. But whenever he was running every day, it was cache. It was taking coming pretty fast, and on the Mondays, for the first time, it has to cache it again. So it might take some time. So you have to look at the caching part and all this stuff. So there is no hard and fast rule why the query was running pretty good previously. Now it's taking a lot of time. Then you have to go investigate. Okay. Query queuing that we have already looked at it, right? Warehouse monitor and then go look at it. This we have already looked at it. So to determine the current load, two factors are considered: current resource consumption, RAM and CPU, the size of the virtual warehouse, the number of queries already executing, the number of queries that can execute in parallel on a warehouse is configurable. So this is the one that we have talked about, right? At any given point of time, how many queries can be executed? It's called max concurrency level. And the statement queue timeout in second. If it's waiting in the queue and gets timed out and the query is cancelled, you don't know what is happening. Why my query is not running? Then you have to figure out what is the timeout settings and look at the load monitor graph and see if the queries are getting queued. That means the warehouse is full or not, running full or not. It doesn't take any new queries, it's running full or not. How do you identify? Go and look at the load monitor graph. Apart from that, nothing else. Okay. Queries spilling to local storage. When you have some scenarios, right? You go and look at the query profiler, and then so it's spilling bytes spill to local storage. 37.59 GB is being sorted out in your local storage. So that's always expensive. You should not allow the bytes to be spilled. It should be the entire virtual warehouse cache only, or one virtual warehouse. If it doesn't have enough memory to sort your data, then it goes and uses the S3 buckets to dump the data into S3 buckets, sort on it, and then get the data back and give it to you. It takes a lot of time. To optimize a query that is spilling a lot of data, the best approach is to reduce the number of rows that must be processed. Try to see the filters and try to see why this much of data is being aggregated or ordered or too many things on a complex query. Data clustering is often very effective for this as it allows Snowflake. So the data that is trying, it's not properly ordered, and data clustering only comes into the picture when it's multi-terabyte of data. Snowflake in many cases to only read the appropriate subset of data that is really needed. Or if you are trying to do this right, the other one more solution is trying to do analytical functions on the query. Rather than doing that, if you do analytical functions, you can avoid this kind of scenarios. Okay. And row explosion. So if you look at, I have explained you right. You have table join condition B is equal to A, C is equal to A, and table A table. So you have joined A is equal to A, C is equal to A. So you don't have A to B. And if you look at the data that is being pumped in, right, the join receives a billion rows from one side and 3 billion rows from the other. 3 billion rows and 1 million rows in the join condition. If you go and look at the query profile, you will get to understand what it is. And if it's passing this much number of data, right, then definitely there is something. And as a join, it's generating more than 20 billion records. Where is it 20 billion? You'll see right 24.222 G on the top. So to filter, so whenever you join, if the joins are not properly placed, and then it goes and gets too much of data for processing, you have to look at these particular join condition nodes. We call them as the nodes. You have to look at the nodes and see how much data is processing between the nodes, how much is the total data that got processed, and then figure out this is bad. And then in many cases, however, it is result of erroneous join condition. If you haven't, and if you go and join with A to B, then you might um, filter out a lot of data that needs to be processed. So if you miss out the join condition, then it becomes a Cartesian. If you have 10 million here and 10 million, 10 million to 10 million, that is the total number of rows that needs to be processed. Look for missing join conditions. This is called row explosion. Okay. Unsatisfactory pruning. So when you look at this particular thing, right, there is a filter condition. First, it fetched the data from the table. Then the data, it was pretty fast. It didn't take a lot of time, 4.7%. And filter condition, 94.5%. That means it worked on it huge. It so it took this is normally look for subqueries in the SQL statement. Snowflake does not do optimal pruning with subqueries. It got the data and based on the filter, it has to filter out the data. It didn't know how to do that, and it took a lot of time. And we talked about 10% of total micropartitions, right? Okay. In this scenario, we see that there is a filter immediately after the table scan, which removed all of the rows read from the disk. This means that performance could be dramatically improved by more efficient pruning. Okay, so some of the conditions that there is no hard and fast rule. You have to look at the filter conditions and then try to change the filter conditions. Why it's taking a lot of time on the change the sub queries or anything, and then try to do it. So data related to date and timestamps are pretty fast than strings. If you want to filter, try to do filter on the dates and timestamp rather than the strings. That is one more thing. Or typecasting, implicit data conversion. These are some of the uh, that means you are trying to filter the condition and you have given where name is equal to or some order number. It is stored as varchar in your database, but you are giving as just the number because the data contains only numbers. So it has to implicitly convert it and then filter it, or vice versa. So it's all number in the database or in the table, and you are giving the order number with quotes, single quotes. Then it has to implicitly convert. So these are the scenarios where the pruning might affect. Okay, control in join order. So you are trying to join two tables. Select T1, join T2, and then T3. And if you go look at the query profiler, it's fetching too much of data when you join with T1 and T2. Instead of that, what they say, right? So looking at the query profile, you notice that Snowflake joins T2 and T3 first. Whenever you do like this, right? T2 and T3 are joined first, and then it joins T1. So you know that the addition or you determine that this is not the fastest approach because T2 and T3 might have too much of data, and the filtering really happening on the T1. So T1 might be a small table, T2 and T3 might be huge tables. So try to filter as much of data when you're trying to join with another table. So that means the number of rows that it needs to process becomes very less. Okay. So in that case, right, you can create a temporary table. So first join T1 and T2, create a temporary table, and join T3. That should be good enough for you to process the data.
So in this case, the first join should be with the lesser records.
Yeah, no, I cannot say that because it's all trial and error. You have to look at all three tables and then see which table when you join first. See, for example, when you join in this scenario T1 and T2, and based on the condition, you might come up with only 50,000 records. When you join T2 and T3, the data that needs to process is 1 million. So which one is better? Because at the end of the day, when you join with T1, the total result will not be more than 50,000 records, right? or it might be based on join condition. You might, so try to minimize the number of rows that are being processed. When you join with T1 and T2, you might end up with minimal set of rows, and then when you join with T3, instead of 1 million, you might end up with 100k. So these are all trial and error. There is no hard and fast rule. You have to look at the query. Each query is different. You have to identify the query and then do that.
Okay.
So this thing, cities, this you guys know. I don't need to explain much about this. With class, they are also called as common table expressions, and then that should be okay. Okay, and then so I'm trying to query this table. Select star from limit 1000. So this is the data that we fetched. If you go and look at the history part of it, right? This is the query. Okay. So if you look at it, and then in this, these are called nodes, and the node with the orange one is mostly used. You have to look for the orange filters, orange colors in this one, and then this is how the data is limit, and then the result set. So if you look at it, 99% of the time is spent on getting the entire data set, and this one will show you how many partitions are there, how many partitions it scanned. It has scanned this much number, this much MB of data, percentage scanned from the cache. It did not get any data from the cache. Okay, and the synchronization. So if you look at this remote disk IO, right, that means it went to S3 buckets to get you the data. Remote disk means S3 buckets. Okay, local disk means from the virtual warehouse. This is from the virtual warehouse cache. Local disk IO means this is serving it from the virtual warehouse cache. We talked about it, right? And remote disk means it's getting from the S3 buckets. Okay, so this is pretty much about. So this is processing. It took about 18% for processing, and it took about 52% to get from the remote disk S3 buckets, and synchronization getting it onto the remote the virtual warehouse cache and to the metadata. This all the total process took about 29%. Okay, let's go back here, and then return date, and we'll look for SR. There is a credit memo. I'm using this to filter the data. It might take time. We are trying to get from how much data is it? 28 billion records. So when you look at this, right, store returns, when you put your cursor on it, is a clustered by SS return date SK, SR item SK. So if you this table has been clustered by two columns. If you use these two columns in the query, your result that is pretty fast. It gets your data pretty fast because the data is auto clustered by these two columns. And now I'm running this credit note, right? So now it's taking a lot of time. If you use the date and then the credit memo, right, then it has already clustered by the date. It gets you the data faster. So these are the things that you have to identify before running the query. And if the query is taking a lot of time, how do you tune them? You go and see if the table is already clustered, then what column that is clustered on, use that particular, because this is a huge table, right?
Sir, any specific meaning for the TCL? 100 TCL, 10 TCL, 1 TCL.
That is the, you mean the abbreviation?
Yeah, yeah.
I
10
don't,
TCL, 100.
I do, I forgot the abbreviation, but if you see one, right, 1 terabyte of data is there in the entire schema. 100 TCL means 100 terabytes of data. This is 10,000 terabytes of data in this entire schema. So that is the notation. 1 terabyte, 10 terabytes, 100 terabytes, 1000 terabytes, 10,000 terabytes. This is 10 terabytes, 100 terabytes. TCL, it has a different schema, and then this one has a different schema. There is some abbreviation, I forgot the abbreviation.
Okay.
And this is taking hell lot of time. So if I go and say limit 10. No, you have to, it's running, right? You can see the thing. You have to see. If not, you go to the query history, you abort the query. So this is the query that we have run. It utilizes this much. And if you will run, right, total duration 2 minutes, byte scan. So this is how you can check whether the query is running or not. It has scanned about 75.3 GB so far, and it tells you what is the client info. We are running from web UI, and total number of records fetched so far 10.3k. 10,000 records were fetched. Okay, and I go there. Table scan 100%. So remote disk IO 94%. See, it was trying to get only 2% of data is from the cache. It might have got some data that we have previously fetched on this scenario. Okay, let's go back, and then we'll say return limit, right? And return date sk is one of the, and this is the credit memo, right? 173122. So for this particular date, we are trying to get the credit memo. I'll run this query. See how much time it took? 1 second. If you have the proper keys, then it gets your data pretty fast. So now when you look at the table scan, it scanned only 35%, 35 micro partitions rather than scanning too much of them. And then create Momo based on the filter condition, you got the data. The total of the time is spent here only. If you look at it, remote disk IO, it's only 25% because last time it has done, it has already cached something and it got the data based on the condition that you have given. Trying to get the data, it took a lot of time. From the remote disk, it's only 25%. Percentage scan from the cache, 98%. You know, already last time when you queried the query, it had in the cache, and it read from this cache. Okay, and this is pretty much about it. And then Narendra asked me a question: how can we know the new version of the Snowflake application version? How will get in real time? No, what was, I did not understand, Narendra. Can you come again? So it automatically updates, right? You don't need to worry about it. The Snowflake version, select star from current. It's not current version. So that is the reason if you use an ID like any other tools, right? Like dbeaver or at least NoSQL, it shows you what are all the functions that are available with. So there is a version thing that you can identify, and it automatically updates the versions. You don't need to worry about it. Current version only I typed. So the 5.21.3, and this version changes every week because there will be a release every week, right? This version gets changed 5.21.3. Okay, and if you want to know the client version, current client SnowSQL 1.2.15. It gives you the version of the file. And once you install SnowSQL, it automatically pushes and upgrades. When I installed it's 1.2.1. Now it's 1.15. So that means it automatically updates the client version as well. Okay, it's a push mechanism that it does. This is your client version, current version, and this is your client version. Why did
Well,
it?
and one more thing, nobody will ask about the version, right? Like, because we don't have any control, and everyone will be using the latest version on the by default, right?
Yeah, sometimes people they are crazy. They want to know whether you can query the version or not. Their intention is not to identify the version. What the heck is this?
Select star, sir. You need to remove star.
Oh, sorry. My bad. I was not even looking at. Okay. I think I have pretty much covered everything in the. So you have this slide query, slide deck handy, and you can say this is what I'm gonna do. I'll look for sub queries, correlation queries. I look for the join conditions, proper join conditions, whether anything is missing or not. Look for the proper filter. Is the query was it running very fine previously? Is it taking a lot of time? I look into the load monitoring graph of the warehouse and see if any queuing is happening, and then. And the other things, right, when it's coming from ODBC or JDBC, you have to look at the JDBC properties, how much data can be processed. There are some properties, that is the next step. Okay, so if some of the connections they are taking, right, apart from that you have to look at the properties. If the properties are not properly configured, then it takes a lot of time. Okay, so I had an issue today for somebody, and then we, so the insert statement it's taking 10 seconds. When we do the insert statement in SnowSQL or Web UI, it takes hardly 1 second. And then they're doing continuously for 4 hours. Each time it's taking 10 seconds. And in an hour, they are running about 22 queries. 22 into 10 seconds, 220, 10.3, 10.4 something. So almost 250 seconds out of 5 minutes load, right? When we go and look at the frequency of the load, out of 5 minutes, the load is about zero point 0.9. When we go and look at the queries, they were all about 22 queries running for 250 seconds. That comes to zero point 0.9 or something. Why is that? So we looked at the ODBC, it's coming from the ODBC. And then we looked at one of the ODBC properties, it was not set properly and modified it. And then it was getting finished in less than um, 50 seconds or 1 minute or something. It saved a lot of time. So those are the things that you have to explore. You have Google, try to see, check, explore, and all this stuff. So these are the things that you have to talk about. Okay, are we good, guys?
Yes, sir.
Yes, sir. Yeah.
This is also done, and we have this credit calculation. We'll talk about this. So when it comes to credits and storage usage, so you normally use the Snowflake database to look at all the metadata part of your account. And we have when we have looked at the privileges security session, right? You should have a special privileges to access the Snowflake database. And when you have the access to Snowflake database, you can query all kinds of metadata and then see what is going on and all this stuff. Okay. So Snowflake database contains four schemas, all read only. Okay, and you go and look at, now they have five schemas. They have one made for shares also, and you have to change the context menu and change it to account admin. Okay, this is Snowflake. So you have now five of them. Previously it was only four. My slide deck when I prepared it: reader account, organization usage, information schema, account usage. The most of them is right, account usage and information schema. And if you create a reader account for this year, then you will have the reader account usage. This organization usage is something like you have a company and the company has four accounts. One in APAC, one is US, one in Europe, one in Australia, something like that. And if you want to look at, you can set up an organization. Underneath this organization, you have four accounts. So when you're trying to look at and query the billing part of it, right? If you want to look at a global level, how much is the total spent and everything, this organization thing helps. I never worked on it. I didn't get a chance because only we had only one particular account that is in US. So, and this is a later enhancement, and now it's picking up because people want to consolidate. Okay, so this is regarding the organization part of it, and it has all the daily read sheet. So these views will help you to give the details on all the account that you have set it up. If you have set up four accounts, and then it summates from these four accounts and gives you a overall picture. This is called organization usage. And coming to the information schema, we know this information schema. Each database has an information schema. Information schema has views as well as it has more functions in it. And these are the views that you're looking at. Okay. And then you have functions. And the next one is both the information schema and account usage schema both are similar. Account usage has more views. It doesn't have any functions. It might, I'm not sure, but my account usage is mostly of views. Okay, and then you can go query and then identify the total number of databases, copy history, columns, file formats, functions, everything. Okay, account usage. So there are some differences between the account usage and information schema as well. So views that display object metadata and usage metrics for your account. These views mirror the corresponding views and table functions in Snowflake information schema, but with the differences. What are the differences? I gave the differences here. See, account usage information schema includes dropped objects. Account usage, yes, and account usage keeps the history for 1 year. And information schema depends, sometime for 14 days, sometime for 3 months, it varies. And whenever you use the function, right, the syncage of the data to account usage schema takes about 45 minutes to 3 hours. Whenever you do create a table, and if you go and look at the account usage tables metadata view, right, you might not see the table that you have created. It takes time for refreshing the account usage here. Okay, and then latency, that's what, from 45 minutes to 3 hours varies by view. Information schema, none. They say none, but it takes it's not real time. It takes a minute or so. Even when we go on, then it takes some time, minimal time, less than a minute or so. A retention of historical data 1 year, from 7 days to 6 months, depends upon, varies on the view. And if you want to enable account usage for other roles, right, you imported privileges, the privilege that you have to give. Use role account admin, grant imported privilege and database Snowflake to role sysadmin. Then sysadmin can also view the Snowflake database. If you want to give it to a custom role, you can give it to custom role, imported privileges. Then you can go and see the whatever metadata of your account. Next comes the information schema. It's also called a data dictionary. Each database will have an information schema. Okay, views for all the objects. So that information schema is only particular to this. If you're not talking, can you please mute yourself, please? Vikram, Vikram, yeah, thank you. And then this information schema has a lot of table functions rather than views. When you use the function, right, it goes and fetches the data pretty fast. And these are all the table functions that I've listed here. Clustering history, copy history, data transfer history, data refresh history. This data transfer and data refresh is for data replication. Database refresh progress, how much has been progress. These details for the replication part of it. Database storage usage history, how much data has been stored for this particular database. External functions, what are the external functions that you have created. External table files, it has all these tasks, task dependent, stage, and then warehouse load history, warehouse metering history. These two are very important. Warehouse metering history, warehouse load history, and validate pipe load. Returns depend on the privilege assigned to the users, current, whether the load is being validated or not. How much of data that is in. So these are all the functions that are part of this. Whichever you wanted, you can do that. Use them and then do it. How do you calculate system usage and billing? So calculate on the daily average amount of data stored in the system. So storage is calculated on daily average. Files that are staged, files that are, if you go and look at this particular billing part of it, right, you will see that account admin. Okay, click on account admin tab. So you see this, right? Warehouses, and this is the storage. Click on I have 270 GB of storage. Yeah, I did some 10 billion records insertion and all this. It's still this is the storage used, and if you look at the total database storage, I have this much, and stage storage I have 4.5 KB of 8 KB in my stage and database, and today I have about 278 GB. What tables are having 278 GB? I don't want to do that. I don't have tables at all. Maybe I have to change. 1 second. These are the tables: employee department, TS test. Why is it showing today also this much? No tables. I have to see why that is showing too much. Okay. So the storage, this is the average storage, and these for the compute credits. The first tab is for compute credits, second tab is for storage. And the storage, when you break it down, it goes by stage how much, fail safe how much. So 176 data of 598 data of fail safe on these days. 12th. Today is what? 13th, right? I have to see why this much of fail safe. And there is a database related, and then there is a stage related. Okay, you can break it down and look at it. Data, so compute usage, and so I have shown you right stage, database, and then the failsafe. Three of them are combined together gives you the data storage. Compute usage is the compute power, right? Calculated based on the number of snowflake credits consumed by the virtual warehouse for all the queries that you are running, and loading and unloading data and performing other DML operations. Okay, cloud services usage. So there is another thing called cloud services where whenever you are trying to use data, that means whenever you use create tables, any DDL statements, or any show commands, or using heavy result cache, these are all, it uses virtual warehouses from Snowflake, right? Not our virtual warehouses, not the custom created virtual warehouses. So these virtual warehouses are they use so, and then people started using a lot of them, and then Snowflake identified it is spending too much money on its own virtual warehouses. So it said if the usage of your virtual warehouse and then the metadata queries that you are running, if it's more than 10%, then they'll charge you 10%. By default, they'll give you a 10% of discount, and then they account it. So I'll show you the calculations as well. These two things I have shown you here. Okay, and then coming back to so let's go and look at here. So this is the uh, total elapsed time on warehouse compute WH. I'm given an explanation here. This is the one. The three things to identify what are all the credits, how much and credits that you have consumed and all this stuff, right? Depends upon these three views. First is account history, The second one is warehouse metering history. Warehouse metering is the one which gives you how much of data that has been consumed on that particular day. So you have warehouse daily metering history. We have warehouse metering history. So for a particular warehouse, it gives a history of the whole thing. Okay, and then so the first thing what I'm trying to do is sum of total elapsed time. How many queries have been run in my query history group by warehouse name. So for a particular warehouse, I'm trying to see what are all the queries that have been run. Okay, group by warehouse. So this gives me all the queries, how much of time that has been executed in my warehouse. First part of it. And then in the second one, sum of the total elapsed time by the warehouse as well as role. So there might be n number of roles that are using your warehouse, right? So if you want to break down on the number of users or number of roles for a particular warehouse, who is using, which role is using. So normally, for example, if you have created 5 warehouses for finance department, and these 5 warehouses will be used by 5 different roles, or might be 10 different roles that you have created, and you want to see, you want the end goal of my query is trying to give which role is using how much of data and all this stuff, how many credits have been consumed and everything. So I'm trying to group it, look at the total elapsed time and group it by warehouse name and role name. Warehouse name and role name. This is the role spent that I have given. Okay. And this is just the warehouse metering history, total number of credits that have been burnt for a particular warehouse. Okay. And this is the query that I'm trying to use. Okay. Let's go run this query. So I'm not going to create a table first. So select is the first query. By warehouse, I'm trying to get the total time by the warehouse, how much time that has been spent on my warehouse. This I have to change it to account admin. Okay. If you look at this, this aspect null. That means this is the time elapsed by running the metadata queries. See, we talked about Snowflake cloud storage credits, right? This comes into it. We'll look at it. Null means it doesn't have a warehouse. This much of time is spent on the metadata part of the queries. This is my compute, this much time. So it has broken down it. So compute WS3XL, it took about this much of elapsed time. So this is order. If you look at it, these are all the warehouses, and these warehouses so far has run this much of queries. And if you want to filter out for a particular a date range, also you can filter out. I'm just showing it for the entire time that I created my uh, trial version of the account. And then there is a second one, which is a role, based on a role, right? From role name. I'm running this. If you look at this, for compute WH, I have public, which ran 310 queries of that time, and then it has been broken down. Public 2075, compute WH, account admin has run this, sysadmin, user admin. It has given me all the roles that I've run upon. Compute WH, sysadmin is the max one because I normally use the sysadmin in compute WH. Right? These are the roles and these are the warehouses and this is the elapsed time. Okay, going back. And third one is the virtual warehouses, the total credit spent from the entire virtual warehouse from group by warehouse name. This is only from warehouse metering history. Okay, run. So credits use, it has given me the credits used for each and every warehouse. Compute WH, my this one 3XL 30 credits. I have run this for the um, resource monitors to burn out, and that was the reason which spent too many credits here. Okay, compute WH, it has spent only 2.54 credits. So this has broken down into warehouse and the total number of credits. So the first question thing is right. How do we get? So I'm joining these two conditions: warehouse spend and role spend and credits used, and I'm trying to get how much is the spent. So select role spend, warehouse name, role spend at role name, total role spend. How much total amount of time the queries have been run for a total role divided by warehouse. If I want to break out the number of credits that are run, right, we have to divide the total number of queries run for each role divided by the total number of queries that have run for the entire warehouse multiplied by credits used for that warehouse. So if I run this, right, so I see, right, compute WH have sysadmin which has used. So for a particular role, for a particular warehouse, I have the explanation also given in another text file you have. We can go through if you are little confused. So my compute WH, where is my compute WH? Let's go and look at one scenario. So this is the sysadmin. Mike, we can compute WH, right? We can filter out by warehouse name once.
Sir, if you are a developer, we don't look at all these things, right?
Why not? There is no clear cut of so if you are troubleshooting and why you have given the role of troubleshooting, why this many number of credits, there is no clear demarcation of the role right now. So everybody is working on everything, right? We don't know. You should have the understanding of what is the metadata table
Yeah, yeah.
views that you have to
Mm.
query and all this stuff, right? So my compute WH, these are in many number of roles: account admin, sysadmin, security admin, test role, public, and out of which 2.19 credits goes to sysadmin. So how did I get this figure credits? I got the total credits for compute WH, and then the queries that ran by sysadmin divided the time of elapsed time of the queries divided by total elapsed time of all the queries that run by compute WH multiplied by the total number of credits. So the percentage of time multiplied by the queries gives me the total number of credits. Understood? Using this role, I have run 100 queries, but the entire warehouse I have run 1000 queries. For 1000 queries, I have got a total credit of 5, 5 credits. So then how much is per role for this particular role? Using this role, I have run queries which had an elapsed time of 100 seconds. The total warehouse was used for 1000 seconds, and for 1000 seconds I got 5 credits. If you want to calculate for this role, right, 100 by 1000 into 5, that is the total number of credits that is burnt for this particular role. And if you want to look it for a particular user, then you have to go which particular user is in which particular roles, and then you can do that as well. So this is the same query, and I have created the same query. I've given one more time by creating inserting into a temporary table. Okay, and so total elapsed time on warehouse. Select some of these in explanation I have given. What of the query that I've run, right? Total elapsed time of sysadmin. For some, for example, by the total elapsed time, which gives me 0.943 multiplied by credits. Total credits will give me this much percentage of time is spent on this particular role, and then that much percentage of credits will also give me which role has spent how many credits. So if you run on your query and then try to replace the values here, right? I'm using for compute WH, and these are all the things. And if you want to look for a particular user, right? And where is the user spent? Yes, modem one, right? When you query using warehouse name, role name, username. So when you have one more grouping based on the role name and username, then it gives you the user details, and you can see which user has spent many number of credits. Rather than a role, you can see the user as well. In the query history, you will have the user, right? You go and see how many queries has been run by a particular user, and then out of the total queries run divided by this is the one, right? So if you look at it, a user, I have run this many, this much is my elapsed time. Okay, and multiplied by the total time, multiplied the number of credits. These are the number of credits. This is my elapsed time, and this is the total elapsed time of the warehouse compute WH. This divided by this, multiply the total credits, compute warehouse credits. This gives me the number of credits that a particular user has been done. Okay, that is pretty much about the differences between different snowflake database, different schemas, account usage, the a lot of latency. It has all the views, information schema, most of them functions, and that is real time. When you are trying to query a function, that gives you the real time consumption, whatever the data that you are querying for. And then you the important views which are part of your credit calculation is warehouse metering history, and then you have query history, which has all the details, how many queries, which role, which user, and all this stuff. And you have warehouse daily metering history as well. And based this is for this one. And you have another for the storage part of it, right? You have other table called storage metrics, table storage metrics. How come I missed? Second. So I have queries for storage as well. I don't know where I have. Somehow I missed it, guys. So the one I'll send you the queries. So if you look at this particular schema, right? Snowflake schema, Snowflake database, right? So this is the important one which tells you how much of data that has been there in the table storage matrix. So this is my schema, this is the catalog, and whether it's cloned or not, and then is transient, no, active bytes, part of the table. Right now, how much data that is sitting in the table, time travel bytes, if there is any time travel stuff, and then if the table has been deleted or not, and all this stuff, and the failsafe. So active bytes, but time travel bytes plus failsafe is three of them combined together is the total storage. So I have some queries somewhere. I'll send you out the queries. So table storage matrix is the view name that helps you with each table how much of data is stored for each table, number of bytes, time travel bytes, failsafe bytes, and everything. This is the one. And when you look at this account tab and then the storage database, right? Those are all part of uh, the same thing. They are read from information schema to give you the data. Okay. And query history, 1 second. Stages, my stage, and then what is the stage region? What else we have? Create, and there is somewhere it stores the bytes of that stage as well. I forgot to tell you. So it has the stage, right? Okay. It storage bytes, failsafe bytes, and the daily average that we are talking about, right? Second day, third day, fourth day. It gives you the entire details. Storage, usage. This gives you the storage, how is it. So whenever it calculates the invoice that you're going to get at the end of the month is a daily average storage, right? So each day it gives you how much is the total storage and how much is the stage bytes and the failsafe bytes. By looking at this particular thing, you can identify what was your yesterday's, day before, and what if there is any spike, right? How much data has been pushed in, and you can, so you can identify how much is the average balance of each day. Okay, got it, right? So basically these are from the metadata part of it, and then I'll send you some queries on the storage part of it as well. But table storage metrics is the only view which gives you the entire table. If you want to look at it for entire schema, you can filter by the schema. Entire database, you can filter by the entire database for all the tables and sum up the total thing. That should give you the total. And this is the one that is used for the account tab, right? The storage usage is the one that is used to get you the data. Okay, I think we have pretty much covered this particular thing. Okay, and we have the other important thing, right? He is also done. I'm kind of little tired today, so this encryption doesn't take more than 15 to 20 minutes. This is also a theory, and then we'll work on UDF, UDETF procedures. This will try to finish it in the weekdays itself, couple of days. If not, next weekend you'll have your last class. Okay. Okay, guys. Any questions for me, please?
Um,
Sir,
sir,
I have a
couple of
question. Yeah,
questions.
yeah, go
Uh,
ahead.
Mm-hmm.
yeah. Is can we have some what is the multi-insert concept, sir? I was,
Multi-insert. You that is basically see when you go and look at the snowflake documentation, right? So see, the biggest problem is I cannot give you all the details about all the entire documentation. That is part of the SQL. If you go down and then look at this particular part of it, right? SQL command reference, so DML commands, right? Multi-insert means you have a data and you are trying to insert into many tables, one particular data set into multiple tables. That is called multi-insert. And if you go look at this, right, the insert command, you will see that this reference you have to look into see multi-table, right? This is the one.
Okay. Okay. So yeah.
I'll might be an example. Insert all into T1 into T1, C1, C2. So you're trying to get select from a different table and you're trying to insert, right? So some of the columns into one table, all the columns into one table and all this stuff. Insert over, right? This is the multi insert that you are trying to do. And you have
Doctor,
a
are we
conditional
covering
multi
this?
insert. Sorry?
Are we covering this SQL reference also?
No,
As
no, no,
what?
no, no. I cannot do this. See, the first prerequisite for the entire course is you should know SQL. I say if I start teaching all of them, we cannot finish. It takes about 3 to 6 months. I cannot give you the entire thing. These things you have to explore. I have given you 95% of the things how it works in Snowflake, the real case scenarios, what are the important things of the metadata, what is virtual warehouses, how do you ingest data, what are the performances, and what are streams and tasks, and what is the resource monitor, how do you set up. So I have given you 95% of the information on Snowflake. And these SQL commands, I expect you to. So SQL commands normally vary from technology to technology. I wanted to explore you this particular SQL reference, and then if there are any things you have to identify. This I cannot tell you.
Sir, I have a question. It's not
Yeah.
related to today's topic, but I have time travel question on
hmm
time travel. Sir,
hmm
generally we set the time travel in account level and object level also, right?
Account level meaning?
Uh, time travel can be set in account level. I mean, for all the objects, when you create an account for all the objects,
No,
this
you're
time
talking about
travel.
the parameters that can be set on the account level and the object
Yes,
level.
yes, 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 yes.
Okay. Okay.
Let's say, for example, in account level, I have set it to 30 days.
Okay.
Okay, so in account level, I'm saying.
hmm
Okay, after 30 days, all the objects will come into fail-safe period, right?
Yeah.
Then, in that case, after 30 days, if I want to have time travel for a new object, for a table, can I have it?
Yeah, by default, so whatever the account level gets carried onto your object level. That is default. You can bypass it at the object level as well. If you don't bypass it, you have set it for 30 days, and the table will also have 30 days of retention period. So you can do a time travel on the entire table.
Even even the account level is expired. I mean, time travel period is
What
gone.
expired?
Then, whenever a new table is get created, then we can have time travel concept, right?
No, no, no. So you're confused. Time travel tells you how long the data has to be retained for you to query. So if you
Yeah,
set it
that
up
is
for 30
correct.
days,
Hmm.
all the tables, whenever you
Hmm.
insert, your table is created today. From today to 30
Hmm.
days, it keeps the data and then goes into failsafe.
Yes.
And you
Yeah.
created a table tomorrow. From tomorrow to
Hmm.
30 days. So each table will have the same property.
Okay. It will not the object level will not override the account level one, right? That's what you mean
No,
to say.
no, yeah, you can overwrite. Account level is 1 day, object level can be 7 days, object level can be 30 days. You go and alter the table and give data retention time in days is equal to 30 days. Then it takes 30 days.
Yeah. One more question, sir. Like for say I have a sales table, I have
Mm,
time travel period of 30 days. It's already over.
mm,
Okay.
mhm.
So after few days, can I go and increase? Can I have fresh time travel period?
Well, why not? You can go ahead and do that. Yeah. You can alter it instead of 30 days, you can alter it to 7 days only.
No. Increase. Can I increase? Not decreasing.
Yeah, if you increase from that day onwards, see, you think sensibly. It has to keep the files, right? If you increase today and if you wanted old files, how can it retrieve the old files for you? So today is one day. It keeps
Okay.
1 day worth of files. And tomorrow, after a week, you modified 7 days. And then from there, it keeps 7 days of files. Instead of one day, it keeps on accumulating. On seventh day only, you can time travel the entire week. From the day that you start alter and then increase the data retention period, from that day, how many number of days that you give, it starts accumulating. Day one, it doesn't do. So on day one, you created a table with time travel of 7 days. You created today. How long can you do a time travel today? You can do only 24 hours or only 3 hours.
Mm,
If you have created a table only for 3 hours, before 3 hours, you can do only 3 hours. You can
yeah.
look at the time travel after 7 days. You created a table today. After 7 days, you can go back to seven days and get whenever you want. You can query the data.
Yeah. My question is like, let's say I have a sales table. I
Hmm.
initially have set the time travel to 30 days. Okay. So
Okay.
10
Hmm.
after 30 days, okay, I did not renew it. I don't want to renew
No,
the
what
sales table
renewal? There is no
for further.
renewal. No, hold on,
Yeah.
hold on. There is no renewal. After
Yeah.
31st day, the first day file will be deleted, and 30 days you will have 30 days. If you are on the 31st day, the first day
Mm.
files that are part of your time travel are gone into failsafe,
Mm.
and you have the latest 30 days. At any point of time, after 30 days, it keeps on the running 30 days for you for time travel.
Running 30 days. Okay.
If you do after 2 months, past 1 month, past 30 days, files will be there with you.
Yeah, yeah. But we can do maximum of 90 days, right?
Yes,
The
yes,
time
yes, that
travel.
is true. Yes,
So
that is
after
true.
90 days, we cannot again create time travel on the same table, right?
No,
We
no,
cannot
no.
fresh.
I did not understand what freshly meaning.
No, I mean like I have sales table. I have created time travel 90 days. Okay, 90 days is
Okay.
gone. Okay, after
Running
3 months.
gone means there is no gone thing here. So you created a table today, and after
Uh-huh.
90 days, you have the entire 90 days for time travel.
Yes,
After
correct.
120 days, after 120 days, it keeps only 90 days worth of data for you to do time travel. The other first month, 30 days, that gets deleted.
Oh, okay. Now I got it. Yeah.
That is what running thing, right? Every time it will keep on 90. The latest 90 days, the previous 90 days, you will have that for you to do time travel.
Oh, okay. After 120 days means like first 30 days is gone.
Yeah, you will
Most
always
recent
have only 90 days.
Okay. Okay. That means
So
as long as the table is there, then we can have the time travel, right?
Yeah, you have to mention the parameter, right? Data retention
Yeah,
time
yeah,
in days.
yeah.
And that has nothing to do with the data that is sitting in your table.
Mm, mm.
So the total active means the number of rows that are sitting in your table plus the time travel retention plus failsafe. These three are calculated together to calculate the total storage.
Okay. Got it, sir.
Hmm. Okay, guys. Right, guys. So let's catch up next weekend, and next weekend will be your last session of the program, and we'll call you sometime later after a week or so, and then we'll go over the extra topics that we talked about. Okay.
sir, for SSMS or other simulation, is there any sample data or something so that we can go and explore sample
What?
migration from SSMS and to Snowflake?
I did not understand. What is SSMS?
I mean, SQL Server to Snowflake, you said the one simulation we might
Yeah,
be
I
knowing.
have done some stuff on using my Python. I can show you that. You can still do if you have SS, SSIS, and then there is this SSIS tool, right? SQL Server Integration tool. You can use that, and then you can pump in the data. And the data, I don't have any sample data as such. You can create some employee table or department table, or you can generate from the sample Snowflake sample data, right? You take SF1 or something which has 1 terabyte of data, the entire schema. You create the tables and unload the CSVs in SQL Server. Also, you can load the CSV files, right? Load them, and you have the tables there. You bring them into Snowflake.
Okay, sure. So we'll try, and if we encounter any issue, we'll let you know.
Yeah, sure. Then. Okay.
Sure.
That
Thank
sir,
you,
Sir,
sir.
no thing, sir.
Thank you.
But
yeah, sir. Extension to the last question, the previous question that I have asked, right? Like, if it is 90 days, you said like it maintains last 90 days data, right?
Hmm.
So
Hmm.
in that case, like we will be having the data for not last 97 days, right? Including fail safe.
No,
If
you
it
will
is,
have 97 days of data worth with you. 7
yeah,
days
yeah,
will be in field safe. You don't have the access to
uh,
it. You have to
yeah,
raise a
yeah.
ticket and they'll help you out. The total
Okay, okay.
97 days worth of data,
97 days, right?
yeah,
Hmm.
yeah, available to you.
Yeah, got it, got it.
So
Okay,
every time the latest snapshot of the table, we can have a time travel on that, and that will be for 90 days, right, sir?
that is true.
Okay. Okay.